All right, well, I mean, this goes pretty quick if you know what to do. If you don't know what to do, then you don't know what to do. So if these are little tangent lines, then we're going to draw a curve through the point 1, 0, and it just follows, all these lines should be tangent to the curve. So maybe we just kind of, I don't know, follow it like this, I guess. Yeah, I'll go with that. I could have done that better. This one, following these tangent lines, probably looks something like this. And then up here probably looks, something like that. So there'd be 3 versions of the same curve, depending on the constant, depending on what C would be. So if C is up high, we're going to have that up higher one. C is a little, maybe -5, then we have 1 down here. So that's kind of the point. That's what we're trying to do today. We're talking about, these are called slope fields. So we're given the derivative, and if we don't know how to do the antiderivative, if we don't know how to find the function, we don't just throw our hands up and go, well, I guess that's it. We can still graph the derivative, or little tiny derivatives, little tiny tangent lines, and get an idea what the original function looks like without really ever having to do the antiderivative. There you go. These are slope fields. We're going to do Euler's method on Monday. We'll do that on day 2. An differential equation, an equation involving a derivative is called a differential equation. The order of a differential equation is the order of the highest derivative involved in the equation. So solving a differential equation. I took a whole class, well, there's a whole class on differential equations in college. They call it DiffEq. It's literally called differential equations. I took that one. Not everyone has to. You can take other classes instead of that one if you're going to be a math major, or even if you're going to be an engineer. They might require it as an engineer. I don't know for sure. But it's just a piece of calculus that you spend a whole semester studying. And you can do that with lots of pieces of calculus. You can just grab a little piece and study it and learn more than you ever want to know about it. And they say that, and what you end up doing is you learn more about a more narrow focus. And they say that some people go to college till they know everything about nothing. And you'll see those career students when you go to college. They look like me, they're still in college, and you're like, what are you doing here? But they just love it. They're starting their 7th degree, and they just love it. And every college has one of those. Anyway, find all functions y that satisfy dy dx. We are solving a differential equation. And if I don't emphasize this, you'll get to the test, it'll say solve the differential equation. You're like, I don't know what to do. What does that mean? Solving is not finding a number. Whenever you solve an equation, you're like, x equals 7, x equals 14. Solving a differential equation means finding the original function. So here's what we do. We multiply both sides by dx, and those cancel. You can multiply differentials like you would a variable. We have dy is equal to secant squared x plus 2x plus 5. Dx. So we split the differentials. Now we're going to integrate. We're going to back up to the original function. So y is equal to tangent of x plus x squared plus 5x plus some constant. Because if we took the derivative of a constant is 0, so it'd go away. That's the solution right there, and we can't find c. We don't have enough information. That is solving a differential equation. It doesn't say x equals 10. That's the solution. Now, how about we solve an initial value problem? So we can actually find what c is on example 2. So dy is equal to e to the x minus 6x squared dx. So we split the differentials. Antiderivative is y is equal to e to the x minus 2x to the third plus c, plus some constant. Like I said, the derivative of the constant is 0. Well, now we have a point. We have what's called an initial value. There it is right there. A point on the curve. And y is 0, x is 1. 1 to the third plus c. So we've plugged in 1, we plugged in 0. So we have 0 is equal to e minus 2 plus c. So c is equal to 2 minus e. We subtract e, add 2. Well, now we go to this spot right here. We take that and we plug it in for that c right there. So the final answer is y is equal to e to the x minus 2x to the third plus 2 minus e. So there's the function with, and we have enough information to find c. We have that point. Graphing a general solution. Grab your calculators. This, I think it's kind of cool. I'm going to show you here. It says graph the family of functions that solve the differential equation. The derivative is cosine. So if we did a little bit of work here, we got dy equals cosine of x dx. We're going to take the antiderivative, and we got y is equal to sine of x plus c. So let's say we wanted to find out, well, what would it look like sine of x plus 1, sine of x plus 2, sine of x plus 3, and kind of get an idea of what the family of graphs would look like if we didn't know what c was. Well, it turns out these calculators they do some really cool stuff. So we're going to go braces. So it's the second function of parentheses. And we go -3, -2, -1, comma. Comma is under sign, by the way. Oh, I need -1 here is what I wanted. Comma, 0, and we'll go to 3. 0, 1, 2, and 3. We'll finish the braces. There we go. And we're going to store that into a list. And list is the second function of stat. So we're going to go second list. So I did store down here, second list, and we're going to store that into one of the lists. L1 is as good as any. So that, and you press enter, that just stored that list into L1. Then you can see I did it, I've already done this today, a couple times actually. We're going to do sine of x, and then plus that L1 that we just stored all those numbers into. So now when it graphs it, it's going to graph 7 different graphs, one for each of those constants. So now when we graph, if you go zoom 6, you'll see a bunch of sine curves. Now we know what sine looks like, so we don't really need to do this for sine, but if it's a weird function that you're not sure of, then there's probably better information. So our answer is one of those dependent on how are we going to find c. Kind of cool, isn't it? How it works? I don't know. Kind of cool. I always wonder, the more I learn about these calculators, the more I wonder, well, what can it do? You know, these are pretty cool, pretty powerful. Slope fields. Constructing a slope field. And I have, speaking of powerful, Desmos does a lot of things. I'm still shocked that it's free, but it is. So if you go, well, you don't have to do this, not right now. If you go to my schedule, or in my schedule, I have a link for Desmos slope fields, so that we don't have to sit here and create them all the time. We can talk about them. Well, let's talk about the default one. Whoever programmed this has a default derivative here. But what do you think this is the derivative of? Look at that slope field, and can you kind of see the shape? Do you know what that is? I bet a couple of you can figure it out. No, but you're close. What is it? It's hyperbola, right? It's a hyperbola. So it would, if you're looking up here, it kind of looks like a parabola right there, but this is a hyperbola because it ends up kind of going straight. Parabolas would probably turn up more. Anyway, yeah, that's the derivative of a hyperbola. What was I going to do? What are we given? Oh, cosine of x. So cosine is the derivative of what? Sine, right? So if I do the derivative as cosine of x, it's going to graph sine. Now I know it's a little hard to see. This one's a little more vague. But if you look at just sine of x, it's sitting about right there, isn't it? Right there? Like that. Can you kind of see that with those derivatives, with those little derivatives? Then you have sine of x plus 1, sine of x plus 2. You can get all of the constants. So that slope field represents what the original function would be if you kind of played connect the dots, if you will. All right, that's a slope field. And Desmos does that very nicely. Let's do this. Instead of using a calculator, I grabbed this from Desmos, and I typed in x plus y. So that is the derivative. Now, with the tools that we know, we don't know how to take the antiderivative of this. I don't know how to take the antiderivative of x plus y. We can do x times y, and we will do that. But I don't know what x plus y is, not by hand. But we can get an idea of what it probably looks like. And we're going to sketch a graph of the particular solution that passes through the point 2, 0. And we already did that in the warm-up. 2, 0, there's 5. 2, 0 is about right here. So would you agree that it looks like it flattens out right there and then kind of follows that asymptote? And then it kind of just goes straight up. I don't know. You guys agree with that roughly? So there it is. Now we're going to try to recreate this slope field, but we're not going to do 100 little slopes. I had -3 to 3s on here, as you can see on your paper, but that took us a while. So I reduced it down to -2 to 2s. And here's what we're going to do. We're going to recreate this slope field. I don't know. Should we do quadrant 1? Let's do 0, 0. 0 plus 0 is 0. So at 0, the slope is 0. 1, 1. 1 plus 1 is 2, so I got to draw a slope of 2. I don't know. Does that seem reasonable? 2, 1 is 3, and 2, 2 is 4. Now it's getting really steep. 1 plus 2 is 3, and that takes care of the first quadrant. I can do the axes too. 1, 0 is 1. 2, 0 is 2. 0, 1 is 1. 0, 2 is 2. All right, so I got first quadrant done. Second quadrant. -1, 1 is 0, so slope is 0 there. -2, 1 is -1, so like that. And -2, 2, that's also 0, isn't it? And -1, 2 is 1, so slope of 1 right there. There's quadrant 2. -1, 0 is -1, and -2, 0 is -2. Now remember, I'm plugging the values into this. Keep in mind, I'm not just making those numbers up. I'm plugging them into that derivative. And we're making these tiny little tangent lines. -1, -1 is -2. -2, -1 is -3. -1, -2 is -3, and that's even getting steeper. That's -4. Now, when we create these, the way that I grade them is I don't get out the protractors and make sure that your angles are perfect. I want to be able to get the idea of the curve from your graph. Might look at where the zeros are. The zeros should be perfectly horizontal. The verticals should be pretty much perfectly straight. So those would be easy ones to check. But the rest of these are just kind of just eyeball it. When you get into slope of 3, 4, 5, 6, I mean, it all kind of looks the same. I get it. But we're doing this by hand. 1, -1 is 0. 1, -2 is -1. 2, -1 is 1. And 2, -2 is, that's also 0. There we go. That's what I would expect to see on your test roughly. The horizontal should be good. The verticals should be good. The 1 and -1s, those should be decent. Then it gets a little sketchy after that, obviously. Any questions on this? And then we can kind of draw a curve through that. But they probably wouldn't ask you on this small of a slope field. They'd probably give you this big one and go, all right, give me a curve. Oh, by the way, if we were to graph it through some other point, like on the other side of the asymptote, it probably kind of looks more like that. It's not doing much on that other side. It's doing a lot more on the right side. Matching slope fields with differential equations. Use slope analysis to match each of the following differential equations with one of the slope fields A through D. Do not use your graphing calculator. In other words, don't cheat. How about number 1? Now here's the way I do these. This is how I recommend you do these. We're not going to start picking points and, what's negative 5, 7? What's negative 4, 3? Here's what I would do. Where are the slopes going to be 0 on here? Where x and y are the same, right? So on one of these 4 graphs, at 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, the slopes are 0. Which one do you think is that happening on, A, B, C, or D? You got to kind of analyze it a little bit. You think B? You guys agree with B, that at 1, 1, 2, 2, 3, 3, the slopes seem to be 0? Yeah, I'll agree with that. So if you look at about right here, these seem to be reasonably, they look like that could be flattening out right there, right? And it is. So that's this is B. For x, y, where are the slopes going to be 0? On the axes, right? Where x and y are 0. So which one of the 4? We can rule out B now. I mean, process of elimination. But where do you think the slopes are 0 on the x and the y axes? Think D? Not A for sure, because it looks like on the x-axis they're vertical. I don't think C, because I'm not sure. I mean, could be. I'm thinking, well, I mean, do you think it's going to flatten out right there? I think I'm going with C, right? Agree with that, C? On which one? D. On D? You think that's going to end up being 0?
Like, it's all on the axis.
Yeah. I mean, this is example 8. Okay, survey says, because I don't know, you're starting to be convinced of either. The match to equation 1 is B. The match to equation 2 is D. Yeah, okay. All right. Where is, let's see, when x is 0, we have horizontal. That's when the top is 0, we get horizontal. And when the bottom is 0, that's vertical. So x would be the y-axis. This would be x-axis. That one's C, right? Is that C? Yeah, that's C. And by process of elimination, what's this one? What haven't we used? A. So horizontal on the y. Horizontal on the y. Ooh. Wait a minute. This one's A, right? This is A. That's not C. That's A. This is C. Yeah. That's the kind of stuff that we're going to be looking for. Now we can't solve this one. We can't solve with minus or plus. We can solve with multiplication and division by hand. So let's solve number 2 if it passes through the point 1e. So we're solving a differential equation. Here's what we do. We split the differentials just like we did before, but we got to get the y's with the y's, the x's with the x's. So we have 1 over y dy is equal to x dx. Divide by y, multiply by dx. The x's are with the dx, the y's are with the dy. Now we're going to integrate. We're going to back up to the original function. So we have natural log of the absolute value of y is equal to 1/2 x squared plus c, plus a constant. Now we're going to plug the point in. E, natural log of E, is equal to 1/2 times 1 squared plus C. On the AP test, so far, if I would have gotten 1 point for splitting the differentials, 1 point for having the correct antiderivative, and 1 point for writing that down. 1 point, it says shows, uses the point. That's what the rubric says. 1, uses point. I don't need to write that down. You don't need to write that down. You can do that in your head all day long. So can I. I'm dumb, but I ain't that dumb. I know what 1 squared is. But if you want the point, write it down. If you don't want the point, don't write it down. It's that simple. They give you a point for showing that you're using the point. Everybody understand what I'm saying? You can do this in your head all day long. You don't need to write this down to accomplish the goal. But I'm telling you how they grade it. Everybody good? I'm not going to tell you every day. I'm not going to yell at you like this every day. But I need you to write this down. Don't skip steps. All right? Okay. I don't know why I looked at you, of all people. I don't know why. Okay? Natural log of E is 1. 1/2. C is equal to 1/2. So you get another point for correctly finding C. There's 4 points. This, if you get this on your AP test, this is worth 5 points. That's a lot. For one problem, that's a lot of points, which is good or bad. If you're really good at this, you're going to get 5 points. If you're really bad at this, you're in trouble. All right, that's the way I look at it. All right, so now we're going to plug the 1/2 into here. We're going to go natural log of E is equal to, nope, not there, excuse me, right here. Natural log of absolute value of Y is equal to 1/2 x squared plus, what is it? 1/2. Now I said you get 5 points. The last point is getting Y by itself. Logs and natural logs always equal the exponent. So this whole mess is the exponent. So Y is equal to E to the x squared over 2 plus 1/2. Now if this was a free response question, you'd be done. You could probably leave it like that. If this is a multiple choice, there are several ways to finish this. We have e to the x squared over 2 times e to the 1/2. Because remember you add the powers when you multiply, so we can split it back up into multiplication. And we could probably write square root of e times e to the x squared over 2. I could see all 3 of those as being a potential for a multiple choice answer. Y equals that. We good? Questions? You want to do the next one? So we solved number 2. Nope, it's still there. We solved number 2, try to solve number 3. And I said number 3 passes through the point 2,4. So y dy equals x dx. Someone in here, or in the other class, maybe out of the 59-ish, I think, BC students I have, a couple of you are going to do this. 1 over y dy is equal to x dx. You're just going to slide the y over. That's not how we get y to the other side, is it? Unless you go a little too fast, unless you don't think about it enough, unless you're just a little careless. Not dumb. That's not a dumb mistake. This is careless. You guys know how to get y to the other side. But if you go too fast, you're a little nervous on the test, you want to do things right, those little mistakes happen. I get it. But try not to do it. You got to multiply that over to get it to the other side, not just slide it over. So here's what you end up with. Integrate. 1/2 y squared is equal to 1/2 x squared plus a constant. On the rubric for these problems, I can show you, we'll see them. You got to show that you're using the point. So 1/2 times 4 squared, 1/2 times 2 squared plus c. We're all smart enough to do that in our head. All of us are. But make sure you show it, please, so that you get that point that says uses point. 16 divided by 2 is 8. 4 divided by 2 is 2. So c is equal to 6. That's the fourth point, getting the correct c. Now, there's a lot of work to get that last point. We're going to plug that into that spot right there. So we have 1/2 y squared equals 1/2 x squared plus 6. Now we got to get y by itself. We're going to multiply everything by 2. What is this shape, by the way? What would y squared minus x squared be? It's a hyperbola, yeah. This one's a hyperbola as well. But we're supposed to get y by itself. So now we have the square root of x squared plus 12, but we got to decide whether to have the plus or the minus. You can't have both. So to decide that, what would I get if we plugged 2 in for x? We would get square root of 4 plus 12. We'd get square root of 16. And we could get plus or we could get minus 4. But what is the point that's given? The positive, right? So this is the answer. That is the answer. Do not put the minus. Now, if it said it passes through 2, -4, we would still get to this point right here, even with the -4, because you'd square it. You see that? You get to the same spot no matter what, because you'd square that -4. Now, if we're given this, then it's y is equal to negative square root of x squared plus 12. So you'll go through all that work, and if you put the wrong sign, you don't get the point, just because of that negative. It's on the right half of the hyperbola or the top half of the hyperbola. Y's first. It's on the top half of the hyperbola. So you can't put the bottom half. So you can't put the negative unless you're given a point on the bottom half of the hyperbola. Then it is negative. Everybody follow me on this? You're good? I don't want you to miss a point because you put the wrong sign. You did all that work but didn't have the plus or the minus. Can't have both. Oh, speaking of AP question, this is a released AP question. Consider the differential equation. On the axes provided, sketch the slope field for the given differential equation at the 12 points indicated. Note, use the axes provided in the test booklet. 0, 0. Should we start at 0, 0? 0, -2, that's still 0. 1, 0. 1, 0. 1, 0. -1? No, -2. Excuse me, -2. So this should be slightly steeper. -2. If you have to write them out, you have got to write them out. 1, 1. 1 times -1. 1, 2. 1, 0. Isn't that 0? 1, 2, yeah. Oh, wait. No, I messed this up. 1, 1. I messed that one up right there. -1. 1, 3. 1, 1. 1. 0, 1. 0, 1. That's just going to be 0, isn't it? 0, 2 is 0. 0, 3. As long as that's 0, it's going to be 0. 0, 0. Okay, we got a few left. 1. If I plug -1, I get 1, -3. So that's -3. If I plug -1 in, I get 1, but 0. So that's 0. -1, Oh, wait. That's not 0. Is that 0? Yeah, that's 0 because 0. Okay, negative 1, 1. Negative 1. Aha, there we go. Negative 1. Negative 1, 2. 2 makes that 0, 0. Negative 1, 3. Finally got it. 1, 1. 1. I think I got it. Letter B, while the slope field in part A is drawn at only 12 points, it is still defined at every point in the xy plane. In other words, listen, we're not going to make you do 100 of these. We have this very tiny window, but realize that it's open to all points. That derivative is defined for everything. We're not dividing by 0, and we don't have any radicals. Describe all points in the xy plane for which the slopes are negative. So when you look at this, how will you know when the slope is going to be negative? When y is less than 2, right. So letter B. When y is less than 2, you'll have negative slopes. So those are worth a couple points. Those will be worth, A and B will be a total of 4 points because we have 5 left. It says find the particular solution, y equals f of x to the given differential equation with the initial condition. Find the solution. The solution is not x equals 7. The solution is an equation. It's the original equation. Split the differentials, right? Get y's with y, dy, get x with dx. So we go 1 over y minus 2 dy is equal to x to the 4th dx. You get it done? Get it done?
Yeah.
Excellent. Integrate. Natural log of the absolute value of y minus 2 is equal to 1/5 x to the 5th plus c. So we got 2 points. We've split the differentials. We have the correct, hopefully the correct antiderivative. Show that you're using the point. The point is 0, 0. 0 minus 2 is equal to 1/5, 0 to the 5th, plus c. Don't skip that step. You can do that in your head all day long. I know that. So can I. Show that you're using the point. That's worth a point. It's worth the effort. That's natural log of 2 is equal to c. So now we're going to go back up to this step right here and plug that in. So natural log, absolute value of y minus 2 is equal to 1/5 x to the 5th plus natural log of 2. Natural logs, or logs always equal the exponent. So all this junk is the exponent. We got to clean this up. So y minus 2 is equal to e to the x to the 5th over 5 times e to the natural log of 2. But what is e to the natural log of 2? It's 2, right? Same bases. Base is e. Natural log, that's a base e. Both the bases are the same. That's 2. So the final answer is 2e x to the 5th over 5 plus 2, because we're going to add that 2 over. That was the original, there's the original function, and that's the solution. That's solving a differential equation. In the past, that's been a confusing instruction. So that's how you solve it. Oh, I really like this one. I like this one. I don't know if you're going to get it. Try it, though. Split the differential, take the antiderivative, and then stop, okay? Stop after you do the antiderivative, because I think you're going to get it wrong. You may not. Prove me wrong. What time we get out of here? 26 today? I got to pick up the pace a little bit. All right. Split the differential. I really wanted you to try this, though, because I want you to get it wrong so that you don't get it wrong again, or you just get it right. What's the antiderivative of the left side? Natural log? Natural log, absolute value of 3 minus y. Everybody good with that? Because you're wrong. Wrong. What is it? Go ahead. Negative. Yeah, it's negative. Why? Chain rule, right? What's the derivative of the inside? -1, right? That's tricky, but I don't want it to be tricky after right now. I don't want it to be tricky. I just want it to be part of what you need to do. You need that negative. If you don't have the negative, you're going to miss a point. Now, there's the good news. If you get the wrong antiderivative, you don't get the point. But now you can get the rest of them. If you keep going, if you work with the wrong answer correctly, you'll get the rest of the points. That's the good news, I guess. All right, anyway, let's finish this up and we're kind of out of here. Let's plug the point in now. Plug 1 in. Negative natural log absolute value of 2. Oh, we better not do that. I mean, we probably would get the point for that, but I don't know. -1 equal the sine of 0 plus, see, I guarantee you're going to get a point for that. So negative natural log of 1 is equal to sine of, well, 0. Isn't that 0? Oh, wait. Oh, yeah. 3 minus 1. 3 minus 1, natural log of 2 is c. We got it. So negative natural log absolute value of 3 minus y is equal to sine of x minus natural log of 2. Multiply everything by -1. I'm trying to get y by itself. Three minus y is equal to e to the natural log of 2 minus sine of x. Logs always equal the exponent. So all that junk is the exponent. How about this? 3 minus y is equal to e. No, let's go. Can I skip this step for you? 2 times e to the negative sine of x. Did I lose anybody there? How about this? 3 minus y is equal to 2 over e to the sine of x. Minus 3. Times by -1. When I say that I make that look easy, I've been teaching for a very long time. I'm a very old man. I make that look easy. And I only tell you that not to go, look what I can do. Okay, a little bit. You will have to practice these. I make that look easy. It is not. There are a lot of steps there that you need to know how to do, and you're not going to know how to do them unless you practice this stuff. So I'll give you the problems to practice. You better practice them, or you're going to get to the test, you're going to get to this problem, and you're not going to know what to do. I make this look easy. But I should. I should make this look easy. Anyway, I only tell you that because students get a little too relaxed with this. Oh, yeah, I can do that. And they go home and like, oh, my God, I have no idea what to do. Hopefully that's not you, but I will give you the practice, and you better practice these. All right.